let's get started. Yeah. Hi, my project proposal is network simulations with Shadow. Testing client networking is kind of hard because on local devnets you usually do not have any kind of latency or bandwidth restrictions, which is just not realistic. So yeah, testnets are also not really nice to test this because deployment on testnets happens usually rather late in the development process. And it's also not centralized, so people just don't update their clients, so you can't really test your changes. Also, there's no central metric collection or anything. So yeah, it's also not nice. Simulations are a bit more, are a bit better, but usually you have some simulation framework that you have to use, like some libraries that you specifically write code for, and then you have like some minimal toy examples instead of full clients, which we actually want to test. So a solution might be Shadow. Shadow is a software that originated from the Tor project, and it basically allows you to simulate full software. It works by intercepting the system calls that program makes. So if the program wants to send some packet, it calls the system to send that packet. But Shadow intercepts that system call, and instead of actually sending that packet, it just simulates some latency and adds some bandwidth restrictions, and then reroutes that packet not to the network, but to some other client running also locally. So basically you've got everything on your machine, but can kind of simulate the network. And this simulation can run as fast as possible or as slow as necessary. So if we have a lot of nodes, this is obviously pretty heavy on the system, so we have to slow down our simulation, and Shadow basically tells the program, only 1 second has passed, if in reality 5 seconds have passed. Or the other way around, so if you only need to test with a few nodes, you can simulate very fast. And this allows us to basically quickly iterate on experimental changes. So my project is roughly planned to be in 3 phases. Phase 1, there is a project called Ethereum Shadow, which was developed by Pop, who is a researcher at the EF in early 2023. And it's kind of a framework for network simulations with Shadow in the context of Ethereum. It supports Geth and Lighthouse right now, but not actually because it's currently broken. So there have been some restrictions back when Pop developed it, and so we can't really use current client versions, which is not ideal because we, of course, want to test current changes. So in the first phase, I want to fix Ethereum Shadow. There will be maybe some changes even necessary in Shadow itself to support all system calls required, and extend it a bit. So I want to use Ref instead of Geth because I'm a Rust guy, and and also I want to make sure that I can actually extract meaningful metrics from the simulation, so that I know if my changes to the networking code are good. And also, the EF Panda Ops guys have kurtosis and have some really nice features. Again, I don't know, to have attacking nodes in the simulation, which is also really, really interesting. So yeah, that's first phase 1. I guess it will take 4 weeks or something like that. And oops, that's too far. In phase 2, I want then, of course, the interesting part, to run actual experiments. So there are some ideas like PIDAS is a really network-heavy change, and there are a lot of parameters in PIDAS, and I want to find out if the specification currently is sufficiently resilient. And there are also some experimental gossip sub changes proposed, so I want to test if those improve the situation on the networking side of things. And then in Lighthouse, there are also some problems to work out. So there is like a message queue which tends to behave not that nicely when there's low bandwidth, because then there's a lot of memory consumption and the Lighthouse crashes. So I want to investigate if there can be some better message queuing behavior. and also stuff like peer scoring. We want to eject bad peers as quickly as possible, but tolerate some network fluctuations, of course. So this might also be an interesting experiment. And there's basically an endless list of experiments you can run. So I guess I will find out some of these details during the project. And in phase 3, I want, if it's successful, so if it turns out that this is really useful, I want to make sure to support every client and also to make this Ethereum Shadow thing to be as easy to use as possible so that other client teams can also benefit from it. I have 2 mentors. H. Manning from Sigma Prime offered to discuss some experiments with me, and also the results, of course, are pretty interesting to him. And Pub from EF Research, who developed Ethereum Shadow, also offered me to help with all things relating to Shadow and Ethereum Shadow. So yeah, I'm pretty happy about that. And that's already for the presentation. Any questions? Thanks for your attention.
It's really cool. Any questions? Anyone?
Online? I don't see the chat, but...
We have trouble with the stream, but... so you said that it's coming for Tor project. It sounds really cool. What is it used for in Tor? For testing?
In Tor, obviously Tor is also a distributed system, and they also want to use this to have large-scale simulations running. So yeah, I guess they developed it. There are some papers about Shadow, and yeah. But it's general purpose, so we can also use it.
The question is it like for clients for full nodes, or also can be implemented for the clients as well?
Well, you can basically put anything into the simulation. So you can have some full nodes, you can have some light client nodes. That's why this is so nice. You can basically simulate a full network with full nodes, light nodes, some attackers also, and you can have anything you want. So I want to make sure to make this easily configurable, so you can also test light clients with that. Yeah.
Currently it works with GAF, and you are going to implement.
Yeah, it works. It doesn't work. It's and unfortunately, as I mentioned, a bit outdated everything, so it doesn't start up. But yeah, it was usually planned with Geth because majority client, etc. in mind, and Lighthouse. But yeah. Okay, thank you.
Just short. How can you tweak parameters to create different type of simulations? You modify specs or?
Do you mean specification? Do you mean simulation parameters or parameters within the clients?
Both, because basically you say you simulate the network.
Yeah. So. Simulation parameters, like the amount of nodes, is rather easily tweakable because you can just, when starting the simulation, you can just say, okay, I want 1,000 of Lighthouse and 1,000 of Geth, and connect these to each other. And their behavior, well, some of those parameters are heavily baked into the Lighthouse code, so they're basically constant. So you might need to recompile it, or if you want to test half of the nodes having these parameters and half of the nodes having these other parameters, you might need to have some 2 branches or something and compile those to compare their behavior. So yeah.
Thank you.
Yeah, awesome.
All right, thanks.
So hey everyone, so I'm Leah. We'll talk a bit about myself before presenting what I'm going to work in the next week. So basically, I'm a Rust developer and backend developer. I work currently at Prefer Finance, and my aims with EPF, despite already doing protocol development, was from a very basic dictate and apply task of my as a developer to move to more understanding Ethereum research, but also to be able to do apply research. So that's why my goal. And as working for a liquid risk-taking protocol, it's very important for me to understand, to have a validator opinion and a validator position, to understand what's the best for the validator. And we developed some features to optimize as again for the validator, of course, when validating and when they're doing the validator duty. And one limitation currently is for the validator, if they want to earn MEV rewards, they don't have their words to say about which transaction will be included. And that's why this topic of inclusion list was introduced. And the idea is to first to include certain transactions in the current or next block. And in that way, the validator can still outsource the block building, but have their word to say about which specific transaction can be included. Um, Also, when I joined the program, honestly, I don't know you, but I was a bit lost. Or from the research proposal to the implementation, how does it work basically? So I've been asking about the month how it works. So maybe you can enlighten me about. But from what I see, you have the Ethereum research proposal, then you have the spec, then you have the EIP, and then you can finally move to the implementation. And for this inclusion list, there was a lot of going back, and there was this EIP 7547 that has been released. So we are basically between the third and fourth step, so between the EIP and the implementation. Also, inclusion lists are in the Scorch scope. So you know they have different phases in the Ethereum roadmap, and the Scorch basically is supposed to improve the validator staking experience, to have a more decentralized liquid staking experience, and improve censorship. So so this IP was released. I think it was last October 2023. Yet there was some controversy, and not all concerns were solved. That's why a new proposal has been released in June, and this proposal is basically when you are doing your inclusion list, there is only a proposal that will release the inclusion list. The idea is to have a committee before that was selected randomly. So you will have a validator committee that will basically agree on the inclusion list. Between it will be broadcast by the proposer, and then you have different aggregation and evaluation about this inclusion list done by the attester. So you can see at the slot n-1, you have this inclusion list committee that is created, and that will basically release a local inclusion list that wants to be proposed by the block producer. And then you will have this two last steps about evaluating and validating by the attester. So this proposal contains basically three functions. Maybe we can add another one that is a pre-function, that is election, or creating the validator committee. But then we have the aggregation on the inclusion links, the evaluation and validation. So what's the situation about this proposal? So as you can see, it was released 18 days ago. And what will be, so if we go back to this, how does it work from the Ethereum proposal research to implementation, we are really in the early stage. So the next step is to define the spec. And what will be my project? Basically, last week we have formed a working group with the different people who want to take part in. And so the idea, as a Rust developer, I will build a POC in Rust for that. So maybe Lighthouse is more convenient for me. And yeah, we will have this going back with the different people reading the spec. So we have this 7 people group, and anyone who wants to join, feel free. So also, the nice thing about today is I was discussing with Daniel, that was in the Lighthouse Discord, proposing to implement this EIP 7547, and now thanks to today, I know basically what is the current state of development for Lighthouse. So I got more idea about how much work needs to be done in Lighthouse. So yeah, so my next goals is to reach the Lighthouse team and to build together this POC for the fossil proposal. That's my plan.
Can you elaborate more on the working group? Like who it is? We've been instant follow.
So I took people in the street and they were no, I'm joking. They all love fossil and no, basically it's more the proposal researcher was been writing the proposal. Yeah.
Okay.
So there's Thomas. First, I wish Barnaby to have more idea about how what was the current situation on inclusion lists and fossil, and then then he redirect me towards Thomas, and then we start to speak. And I don't know, in 2 or 3 days, a lot of people wanted to be in, so we have
Nice.
7.
And it's public. It's
At the moment just a Telegram group, but maybe we can move to a more public
it's alright.
working group now. But you are right.
Yeah. That's great.
It's always better to have more.
Did you say that you're the only fellow working on the project, though?
I think so in this group, right?
Cool.
Yeah.
Yeah, awesome.
But anyone is welcome to join because I just heard some other people wants to work on fossils, so I think it's more motivating to have multiple fellow in the group.
Yeah, awesome. Any questions? Any comments? Did you also look into Grandine client? It's also in the rest.
I'm more familiar with Lighthouse to be honest, but I can look also. Yeah, I will keep in mind. Yeah.
Just because you have the Lighthouse question mark, so I was just wondering whether you're deciding or.
Yeah, I'm not sure yet, but yeah, I can look also. Okay.
Awesome.
For sure, I will not do in Golang, but that's my only opinion. But
Okay. Awesome. Yeah,
Thanks.
thank you so much. The panel. Fork choice enforcing. Okay, sounds interesting. Hope so. Go ahead. Yeah.
So it's afternoon. Good afternoon, everyone. I'm going to talk about fork choice enforced inclusion list. The second presentation was also this one, and I was not aware about the working group. So maybe after this stuff, we could be able to collaborate and get in sync on this project. So the issue we have right now on Ethereum mainnet is that we have this centralized block builders who have huge amount of capital on chain, off chain, and they are doing sophisticated transaction ordering and extracting MEV. And that is centralizing the whole process, and little by little we are forgetting ethos of crypto and blockchains, that is to have a censorship resistant system that have treat people equally. So and as a result, over the past few years, there are multiple EIPs to basically stop this. You can see right now over 60% of builders, they filter transactions based on sanction notices, and these builders, they comply with US whitelist, and they are censoring any transaction that is related to addresses in the sanction list. On the other hand, validators, they only filter 10% of the transactions. So we see that there's difference here with how validators behave and how builders behave. So what if we could just get rid of all these sensors, basically. And here's the design. All the credit to authors of the fossil. I'm just going to implement this design in my project, this is on each research by four authors, Julian and some other people. I don't remember all the names. So basically, the main idea is to have two committees for have committees for the inclusionists. One inclusionist committee and one attester. Uh, we have like two slots n minus one and slot n. In the slot n minus one, we select a group of validators from validator set with random variable parameter in the beacon chain, and we basically create this group. And this group, every member from this group creates their own local inclusion list, and they broadcast it to everyone. And the proposer has to basically aggregate all of this like local inclusion list and create aggregated inclusion list and include transaction into the block based on that inclusion list. The later slot attesters are responsible for evaluating the transaction list and inclusion list, and they are going to basically verify the block based on this inclusion list and transaction list, and they are going to either like accept the block or reject the block. It's like a very like simple approach, and it's like in my idea, it's a framework that we can like later on build on top of it. Like you can like play around with the evaluation function. You can play around with like uh, this how you select the committee of within this committee, or how you select a tertiary committee. For example, Vital has also posted another proposal about choosing this inclusionist committee based on that attester committee. Right now in this framework, there is no hard rule to how you select these committees, but like for the like sake of POC, I'm going to go with the like random model. So the specification is on two layers. It needs changes on two layers, both execution layer and consensus layer. On consensus layer, we need to introduce a new object inclusion list that is like area inclusion list, a local inclusion list, and aggregated inclusion list, and a function that is aggregating this local inclusion list. And another function for evaluating the final like, transaction and inclusion list. So it's like eval function. It is taking inclusion aggregated inclusion list that is based on attester's view, and the other inclusion list that is based on proposer view, and delta parameter, and based on that delta parameter and share of like basically intersection between these two sets decides to either reject or accept the block. These are like changes to consensus layer, and for the execution layer, we just need to add a new API to API engine for mempool to receive an inclusion list from the mempool. So this is also one of like functions that you can play around with it, or you can just go like very naive and just select random transactions from mempool. So yeah, and yeah, this is the like diagrams. Just once again, for the sake of to be like more explain a bit more. This is like sequence diagram. We have like block proposals who requests inclusion list from committee. We also need to introduce new methods on network layer for getting the inclusion list from other peers. Then aggregating this and building the block. And for the next slot, attester is going to evaluate the block with aggregated inclusion list, and it's going to either reject or accept the block. I'm going to make these changes on guess, and Prism, the Golang implementation. So that's not overlapping with the project proposal, which is going to be on Rust. So that would be ideal if we had like in Bangkok that we have a DevNet that is running both Rust and Go, and they're like communicating with each other, and they're working in sync. Yeah.
That's very cool. You are doing that.
So yeah, thanks.
It's a weird screen size. You need to either just yeah.
Okay, hi everyone. Today I'm going to talk about something that I've been thinking about for years. So it all started a couple of years ago when I saw a debate on Twitter where basically the Bitcoin maxis were saying that it's impossible to get the total ETH in circulation, right? This was, I don't know, like
August 2020, I know exactly.
Yeah, exactly.
August 2020.
Yeah, it was a couple of years ago, and I mean, a lot of uninformed people like argue that it's just there's no way to fetch the ETH supply. So I mean, for people that work in Ethereum, you know that like you can like very succinctly get the supply by there's a couple of options that we're gonna see now, but I just let it pass. And in this cohort, I saw the proposal of Team last year to basically ingrain like a correct way in a JSON RPC to get the supply. And the motivation is like one transparency. I think it's like it doesn't hurt to have like a function that just like spits out the total ETH in circulation, because right now like centralized providers like I don't know like CoinGecko or CoinMarketCap, they do it in different ways. But if you want to like get the total ETH in circulation by yourself, you need to either modify the node and do a couple of changes, or like basically type in like all the issuance rules since the beginning. So the project is basically almost ready, and how it's gonna look is you're just gonna like fetch the ETH total supply or ETH get total supply, whatever. You're gonna input like the block number as a parameter, and it's gonna tell you exactly how much ETH is in circulation at that block, and it defaults to the latest. In order to do that, there are basically two options to do that, two main options. So first, like after Ethereum migrated to proof of stake, the ETH accountability was split into two. So you have the ETH in the execution layer, and you have the ETH in the consensus layer. So in order to get the ETH in from both layers, from the consensus side, it's simpler in a way, like how we have it right now. You just iterate through all the validators' balances, and you just sum up the total balance. It's a little slow, but you can optimize it. From the execution layer, there are two basic options. One is that you need to iterate over the entire state and sum up all the balances. That's super inefficient and puts like a lot of burden to the node. And then the second option that Sina from Geth helped me devise it is there's a live tracer currently in Geth, where on every block it just tells you the delta of ETH, and basically you save all of that in a file that's currently on mainnet already. And with this new JSON RPC, it's going to be able to iterate over like the entire chain when it's syncing, and it's going to spit out the total balance. Once you have the total ETH in the execution layer and in the consensus layer, you just like sum up the balances and subtract the deposits. This can also, like, the idea is that it's client compatible, so you're going to be able to do it with Geth, with Reth, with Nethermind. Like, probably each client is going to be a little bit different, but the specification needs to be the same. So we're going to choose with the option number 2. Then, like this, like the simplified like mental model of how the things work, a user is just going to call the ETH total supply like any other JSON RPC request. Then once the node receives that, it's going to do the execution layer and the consensus layer like in parallel. from the execution layer, as I said it before, it's just gonna sum up all the delta from since Genesis to the last block. But you only do that once, because after you do that request, you just cache the result, and then the next cycle is just gonna be way faster. And from the consensus side, how I mentioned, just sum up the validator balances. And then you just like subtract the deposits. Then at the beginning, it's going to be like an optional flag, because we don't know how much extra resources we're going to put on the node. So those are like the challenges, like really measure, memory, disk, IO, that's very expensive, and CPU usage, because we don't want to put like extra burden to the node. And hopefully like the extra resources needed to do this are quite low, so we can implement this like as a default, and not as an optional flag. I mean, the goal of the project is this, and again, like the main reason is that I think it's very important, for transparency, and not so much for the people in the like deep inside the Ethereum community, that they know like how this works, but more, as a like, first of all, to eliminate that stupid debate that you cannot get the total ETH supply, and second of all, because since I saw it, I thought like it was going to be implemented, in a year or 6 months, but after 4 years, I didn't see it implemented, so I'll just say I'm gonna take it. So yeah, thank you.
All right. So, hi everyone, and then I'm going to. No, it's not framing the set frames, because it's in PDF, doesn't it? So I'm going to talk about my project, which is the specification of EODS, or what this is the acronym I named Enshrined Operator Delegator Separation. So what does EODS stand for? I just said it's basically the separation between operators, node operators, delegators, and
You can try to speak this way.
sorry. Okay.
So it's this way.
Yeah. So again, EODS, it's about separating operators from delegators at protocol level. So basically introducing an explicit mechanism to have a delegation on chain. It results in an even further separation than of the validator role. Now we have EPBS getting PR'd and implemented. And post that, EODS could be like a even further separation of or unbundling of the validator role. Why is it important, and why can it be done off protocol? So, paraphrasing Vitalik, we need to find like a community approved solution for what we do regarding the large ETH holders that want return for their participation in protocol. They might be lazy, so they might just, if we fail to come up with a solution to this, they might just continue to put their assets in centralized solutions, like we see today in staking, and we do not have like a meaningful role today for these delegators. Second line behind the philosophy of enshrining this separation would be bolstering security, because once we would have separated ETH delegators from node operators, we could actually improve security protocol with giving delegators something to do inside. In consensus, like be part of a light consensus mechanism that could improve censorship resistance. For example, delegates could, first of all, they could be like opinionated. So
I'm a large ETH holder and I want to delegate to a certain node operator based on certain criteria, and second of all, like a delegator, I could input or bring my input into the inclusion list gadget, for example. Why can it be done off protocol? Because we're kind of already doing it off protocol, and we see the current state of centralization of liquid staking. So, yeah, underlining again the reasons behind the why, failing to have a solution for the large ETH holders could lead to further centralization in staking. So the project will be split in two parts. The first part will be a more practical one, meaning the actual writing of the specification, and the second part, it's more of the philosophical research part of the project. Yeah, the research part would be about finding and tuning this role, about what could a meaningful role be for delegators in Ethereum. So moving a bit more into depth, first part, writing the specs. So today there's no way to delegate in protocol. Everybody delegates indirectly somehow using staking platforms, more or less centralized. And the solution of the project would be to provide this explicit delegation mechanism where delegates would use the deposit process that we use today, but use it to deposit and then actually delegate to targeted operators that could be of their choice, and even initiate delegated triggered withdrawals. I don't have a real name for that, but basically that's the idea, that a delegate could ask to get its principal back from that certain node operator. So a bit of a high-level view of the workflow. We could add some lines to the structure that is now depicting that is now the deposit process. So basically, I think we could. I have a straw man in the project proposal. I'm not going to get into that detail, but basically we can add new fields like, is this a depositor, a delegator, or like a Boolean variable? Is it delegator? Like, it can be true or false. We can add the pub key of the targeted validator if you are a delegator, and obviously the pub key of the delegator. Then inside beacon state, there will most likely in the strawman that I'm drafting with Barnaby, we have like this new class in the like a new container called delegator, and basically we would get like this in protocol delegation, constructing the registry of delegators alongside with the registry of validators, like index and balances separate from validators. What I see as deliverables for part one would be the actually changes that needs to be done to consensus layer, to beacon chain, to validator. I don't think fork choice would need to be modified. In the second part, the research part, a bit more tricky. It's about finding that role for the delegator. Already by doing the first part, we would get like opinionated delegators to be able to put in their opinion by choosing the actual validator, the pub key of the targeted validator. but also there's a lot of work to be done in researching how delegators can input their view into those censorship resistance gadgets. I've been talking about, obviously, inclusion lists, multiplicity gadgets, but we were just talking today that multiplicity gadgets most likely gets annulled by fossil. And in the rainbow staking framework, there's something about even light validators, because I'm sorry, I failed to say this. The delegators would need to run light nodes and basically provision light protocol services, and that could even act as a backstop or alternative signal to Gasper participants. So we would not get, most likely we would not get delegators to be finality participants, maybe more like on the periphery of the consensus, like a light service. Okay. I basically talked about this. Yeah, after reading the Orbit SSF these days, I realized that there are consolidation incentivization, calculation or formulas that we need to come up with in the scenario of SSF. Like how do we design consolidation incentivization? How do we design risk-adjusted rewards? And I think I'm going to see this during the project and the research, but I think the protocol could use this signal of are you delegated or are you just not operating when calculating this risk. These risk profiles of finality participants. Again, about delegators trigger withdrawals. This should improve stakers' user experience, and the whole project theoretically should, work on these solutions to find decentralization solutions for liquid staking. Short on the roadmap, I'm splitting the project in two, 8 weeks for first part, 8 weeks for second part. And challenges, like Rodriguez said, of course is not similar, but its memory cost and computational overhead will influence the design most likely. And I've been having some discussions with Potuz for him to look over the design, because most likely it would be built on some specifications that would include EPBS, I reckon. Yeah, I encourage you to take a look at the project proposal and for a more in-depth about the project. And if there are any questions.
No questions for Dan?
Anyone on the stream, maybe? Nothing?
It's not, I don't see the chat.
So,
Yeah, it's empty.
question,
Yeah.
Like, sorry if I didn't follow, but have you proposed this on this Ethereum search platform?
No, I've actually, I have like a straw man together with the mentor, with Barnaby, and we're trying to, actually we have the straw man is drafted,
Yeah.
and now during the project I'm going to build on it. But I just discussed formally with Barnaby and with Potuz, and they will take a look at the design.
And do you plan to publish it before moving to the spec?
I haven't thought about it, actually. Yeah, it's a bit.
Sorry.
Yep.
Finish,
No, it's okay.
I wanted to ask, just so I understand the problem maybe a bit better, what is preventing someone, maybe it's not an issue, if they are operating a node and they simply use a different address to delegate to themselves running that node?
Then they would just be delegating to themselves. It's like,
So what is the problem that's solved if that's still possible?
well, researching for the project, and this includes like research I've read by whomever, because everybody has like the same idea. It's very hard to impose so disruptive changes and not affect staking businesses. So I think first of all, maybe it would be like an opt-in stuff, and some people will choose to do this to improve protocol security. Some will not pick it up. If it could be like implemented like like mandatory, I don't know. It will have to come up during the research part and during the EIP, I think, because introducing delegation, it's disruptive somehow, because at this point the protocol just knows stakers, so it's the protocol is happy, quote by quote, to just know these actors which are stakers. So now we're introducing a new class, and how do we do that without breaking stuff? Vitalik says in one of his posts that at the beginning, maybe it's an opt-in thing, like we just do it to improve security. We'll see how it plays out. Okay.
Hi, I'm Gilia, and today I'm going to be talking about benchmarking and pushing the limits of SSC. So at first, you guys may remember, I was looking into RLP serialization. After talking with some people in the community, I decided to pivot to looking at SSZ instead, because that's where most of the community effort seems to be going into, and possibly more room for improvements. And I picked up serialization because I wanted to work on so-called nuts and bolts of the protocol for this core dev fellowship. I thought it would be a good experience and something I don't usually do, like looking at I guess lower level stuff in a protocol. And yeah, so I'm going to move on to the agenda. So I'm going to be talking about what is serialization and SSZ. Then I'm going to talk about benchmarking SSZ, and then a high performance implementation that I want to work on, and finally the roadmap and challenges. So what is serialization? Well, serialization is when you transform a data structure into a format, usually in array of bytes, that can be stored and transmitted over a network. And so data structures regularly can't be transmitted as is. Can't be transmitted as is, so it must be serialized on one end and deserialized on the other. And this is especially true since their in-memory representation might be different from one implementation to another, especially because we have a bunch of different clients and different languages. So this requires a common encoding format for the protocol. SSZ, simple serialized, also known as SSZ, is a new serialization scheme on Ethereum 2, meant to replace recursive length prefix encoding, RLP, on Ethereum 1. It uses a schema to determine how to serialize and deserialize data as opposed to RLP, and which is good because schemas are must-have in a performance serialization format. and it also allows for some level of direct access. It's deterministic, like RLP. So when hashed, or the data always serializes the same way, which is important for consensus, right? You don't want to somehow get a different serialized output when talking about the same data. Over here, I have a nice little screenshot from the Upgrading Ethereum book, which shows how an index attestation is serialized. Gonna move on. Sure, on time. Next, I'm going to talk about Merkleization. This is how we create a short digest or a hash of serialized objects in Ethereum, right? Naturally, you could just hash an object, but what happens, especially in a large network like Ethereum, where updates may happen to some parts of state, is you don't want to have to rehash the entire data all over again when you're only modifying a small part. Merkleization is a way to hash your data into a sort of, Merkle tree kind of structure in such a way that modifying a small part of it only requires a few updates. And you can just reuse the same subtrees you've hashed before to recompute your root hash. So along with SSZ, this method for constructing hashes of complex objects was devised for consistent hashing across the entire ecosystem and like different clients. Yes, it's also useful for small proofs for light clients that don't want to hold too much data. So now that I've talked about what serialization is, I'm going to go into the projects, two little projects that I want to work on related to SSZ. Notably, a tooling for benchmarking SSZ crates, starting off with like Rust implementations of SSZ. Yes, so I want to create a benchmarking suite that can test any crate that implements some sort of encode or decode trait and compares how they perform against each other on the same data. And so this would work with like some blockchain data set, either just like obtained some, not too sure about how yet, but obtained somehow, or either on like real-time blockchain data as it comes in. And so I have a few ideas for how we could show performance. Have some random images here just to kind of show the gist of what I'm going for. So I'd like to use some sort of differential flame graph approach to kind of see what's happening under the hood for different implementations, to see why one implementation might perform better than others. I'll get a little bit more into flame graphs later on in the talk. Obviously, we can plot runtimes against each other, like how they differ on speed, and then also some useful and insightful reports on performance. This is something that I find is like missing in the ecosystem. Not so much. There's a lot of like SSZ implementations, not a lot on how they differ, what trade-offs come with which, and how they really perform against each other on like actual blockchain data. And then next, so the benchmarking suite was a practical project that I could definitely deliver, whereas I'm also curious in a high performance SSZ implementation. But this is more of like a research project, which may or may not pan out, but I think there's some interesting ideas here that I want to try. And so I had some ideas for possible improvements, like implementing like SIND instructions, notably for decoding little Indian integers that SSE uses. But we can also use it wherever it makes sense. That's still to be decided. And then next, I want to talk about taking advantage of how we hash these serialized objects with these so-called sponge hash constructions to iteratively encode and absorb the input in lockstep fashion so we can serialize and hash in a single pass. So I went into earlier about how we serialize and then we Merkleize so that we can obtain a consistent like short digest that all clients can agree on. Sure, you can optimize the serialization and then optimize the hashing, but if you know you're going to do both, maybe there's some sort of implementation that's aware of the end-to-end flow and can take advantage of this. So I'm going to talk about these sponge constructions in the next slide. So everyone here is familiar with Keccak 256, the hash function. Did you know it belongs to a class of hash functions called sponge constructions? And so these, there's even a nice little image here. These work by two phases, an absorption phase and a squeezing phase. So in the absorption phase, your input is split into these R-sized chunks that are iteratively absorbed into your initial state S. Once the entire input is consumed, then you squeeze it out into your 32-byte hash. So I was thinking, what gains could we have if we start absorbing as soon as an R-sized encoded chunk is ready? And would that mean that we're able to hash and encode and hash in a single pass versus encoding and then hashing, which is two passes? And I think even a small speed up might be meaningful considering we're doing this a lot in the protocol. And so I was curious about this. For the timeline, I'm not too sure on the amount of weeks yet, to be honest, but I have these 4 phases where I implement the basic functionality of the benchmarking suite and I test existing SSE crates. And then again, I'm thinking the flame graph part will be the most difficult, so I'm going to leave that for last in the benchmarking suite. Next, working on the my SSE crate, starting with the encode and hashing functionality, and then adding vectorization wherever possible. Next, I would continue working on the crate, and then test the new crate on the benchmarking suite and see how it performs. And then next, write a report and documentation and how this encode and hashing idea might be of independent interest. Next, the challenges. There's a lot of them. First of all, scoping issues. I might have to tweak the ideas here to make sure that this is viable within the time frame of the cohort. Second, flame graphs are typically used for testing how one implementation runs. Flame graph diffs will compare how your current implementation compares to the last one. And so it's not really a tool for comparing 2 different implementations, but I figured there might be something we could do here given that we're implementing the same traits. So it's the same functions, the underlying implementation might be different, but there might be some overlap. Thirdly, adding SIMD vectorization will make the implementation a lot more complex, which might make it hard to maintain and upgrade. And then lastly, a major concern with this encode and hashing in lockstep idea that I brought up is it's possible that the tooling needed to kind of manage this encoding and hashing sequentially might introduce overhead, which would just get rid of any potential gains that could have been got with this approach. And hence why I left the implementation to the end of the cohort, because it was more of like a research idea. I wanted to try some stuff out. Yes, that's it for challenges. You can find me in my email or on Twitter. That's also my Discord username if you want to find me there. Any questions? Yeah, thank you for listening. Yeah.
Have you already seen Peter?
Peter, I was going to ask you about Peter's new thing. Yeah, have you seen it?
I saw him tweet about it. Did he try that stuff?
Peter started a new SSD implementation like last week.
That's.
He's working on benchmarking it against fast SSD in a few other places.
Mm-hmm.
So have a look at that first comment.
Okay.
And second comment, if you're looking at research implementations and you want a place where it would be insanely high impact, that's probably a place to put it. Because the chances that it goes in the gets in the future is not zero.
Okay.
Yeah, look into the Peter's new implementation. Like the optimization that he made might be interesting.
Okay.
But also like suggestion for him to improve it further. And like one things you can benchmark against when you make your own, for example, as well. You know.
So,
and maybe see his benchmarks, like how he handles it. If you haven't seen it yet.
So
Yeah.
the chances that he's open to design decision changes are very high right now, as opposed to if you go to him in like 6 months.
I see.
And I think he's put his benchmark strategy down there already.
Yeah.
And I actually quite like the approach. As far as I understand, he's taking the objects from the consensus spec tests, the SSE objects, and then passing the encoder and decoder on that. Because the consensus spec tests are technically implemented by like every client.
Okay.
The SSE implementation should be able to pass them.
Okay.
So you kind of already have like this thing of actually what is happening in the client,
Mm-hmm.
and then you're benchmarking the different outputs. So that might be a nice way to generate something else.
Okay, yeah, thanks for the suggestion. I saw the tweet when it first came up, but it was only like 2 tweets about it. I didn't really see much progress yet, but I'll check it now.
In his GitHub, Peter something / SSE. It's SSE repo in his GitHub, and you can find it. The benchmarks. He has like 2 tables with flow, with stream of bytes, and object. So you can see the numbers. So there's something to compare to, and you have some strategy to do. Yeah, check it out.
Okay.
I mean, it's really cool. So I think like it can really help him or you if you both if you look into that.
Okay, nice.
Awesome,
Yeah,
awesome.
I'll do that.
Yeah, cool. Anything else?
All right.
Yeah, who's after Ilya?
Thank you.
Oh, there.
So, good afternoon, everyone. So, today I'll be talking about what I've been working on for the past few weeks, and I've been basically looking around consensus-related research and finality-related research, and that is something that I want to continue during this fellowship, and that is my topic for today. So, it's going to be how can we achieve secure, speedy finality. So, SSF. Now, SSF stands for single slot finality. I'll get to why I use this term later on in the presentation. So, before I start out, a little bit about myself. So, hi, my name is Yash. I'm a final year engineering student, and I work at Authentic Labs. And yeah, I'm just in general interested about consensus mechanisms, protocol engineering, and Zig as well. So, getting into it. So, currently, the consensus mechanism in Ethereum is Gasper, which takes around 13 to 15 minutes to achieve finality, 2 epochs. And that has a few problems with it. So, like Gasper, one of the problems that Gasper has is like it has 2 mechanisms like intertwined with each other, because of which there are a lot of like reorg related issues and a lot of complexities in the mechanism itself. And also, waiting 13 to 15 minutes for a transaction to get finalized is also something that is not good for user experience. People don't tend to wait that long to confirm a transaction. So there has been a lot of research done to bring that down, possibly to a single slot finality where you propose a block and before the proposal of the next block, the previous block is already finalized. Stuff like this is already implemented and works in other consensus mechanisms like Tendermint. But like one of the reasons why we cannot just copy paste is because Tendermint is not available if more than a third of the total validator set goes offline. So it has availability issues. Ethereum does not want that. Ethereum wants to be available even if like the majority of validators go offline. So we need to come up with something new, and that is basically what FFF research is. Before going into that, let's a very quick overview about Casper. I'm sure that everyone here is highly familiar with this, but basically, yeah, there are two mechanisms: LMD Ghost, which basically is like the availability protocol. It tells you like which block is part of the canonical chain based on like the weight of the votes on each subtree. And then there's the Casper FFG, which is which basically finalizes blocks in like every two epochs. So what happens? Like the main thing here, if anyone is unfamiliar, is that there is a link from one block to another block in Casper FFG. When like basically when you vote in an epoch, you are basically saying that okay, this block is correct. Uh, so basically, what you're doing is you're justifying that block. So like when someone links to your block, that block is justified. And then in the next epoch, if someone links your block to justify another block, that means that the previous block has a like the justification has been acknowledged by everyone in the network. So this block is finalized. So like yeah, this is just a rough overview of Casper. So, like the important thing is that in order to achieve finality, you need basically two rounds of confirmation. One to understand that the thing that is proposed is correct, and the second time to ensure that everyone in the network did have that same opinion as you. And yeah, these like are the problems that are with Gasper, like the reorg-related issues, uh, interaction-related issues between the two mechanisms, and another thing related to UX is that the time is quite huge. So this is a proposal that was put forward by Francesco and Luca, I think sometime last year, uh, where what you do is that you divide the slot into four separate subslots. So I think right now there are three separate subslots. You add another one, and as you can imagine, the other one is like the second attestation inside that slot only. So like you have the proposal, then you have the head vote, which is like listed there, and you have another thing called the FFG vote, which is which is used for the fast confirmation uh, of that block, and then you have something called the acknowledge, and then you can go and propose the block again. Like the current problems in this, like potential problems, is that doing two rounds of voting inside a single slot can cost a lot of overhead. You cannot just have two slots because, like, since the validator sets are also increasing, what happens is that aggregating the signatures and like collecting it, gossiping around in the entire network gets really costly, and it takes a lot of time. So, like, the timings of the slots and like the sub slots will increase a lot if we use an architecture like this. So there has been more research into this, and algorithms like Orbit SSF, which was quite recent. It was like legit. The Orbit SSF ETH forum was released, I think, last week or like in the last 2 weeks. So it's quite recent. Basically, what it says is that you either like have a cap on the economic security, or basically have a cap on the validator set. So you get like currently in Gasper, what happens is that whenever you like propose a block, so like because of the Ethereum consensus, it's kind of understood that okay, most probably this block will be finalized, because like if it is not finalized, then something has gone wrong, which is not probable. But like yeah, until finality, there will be no slashing. So like if there are any reorgs before finality, there will not be any economic loss to anyone, and then after finality, there will be you have economic security after two epochs. So what Orbit SSF does is that it breaks the committee sets. So like after each slot, a small committee can attest to attest to a block and finalize it within that same slot. It's like a very small committee, so that you don't have problems like how do you handle such a large validator set, and how do you aggregate so many signatures and stuff like that. So you have small committees which keep attached to it after every block, and then slowly towards after a few slots you might have the full economic security. So this is like the current state of research in this space. So what I recently read is that Vitalik recently published a blog, I think a few days ago, which was about slots and epochs, in which he mentioned what can be done to increase finality, to like improve finality on Ethereum and on L2s. And there are a lot of slot and epoch related architectures. Like there's the original SSF architecture. There is this Orbit SSF that's new. A talk given by Francesco in the ETH study group. If someone knows that, in that talk also he mentioned about another proposal that they might be working on, something like a 3 slot finality. So like you achieve slot finality after 3 slots. Like there's a proposal in one slot, there's a head vote in the other slot, and then there's a confirmation in a third slot. So there are a lot of different algorithms and models out there, and even Vitalik in that blog that I was talking about, he mentioned something that like the L2 pre-confirmations. If you make pre-confirmations committee based, then that is also somewhat similar to having single slot finality, but on layer twos, right? So there's also, so basically this entire space is quite raw, and what I hope to achieve during the course of the next 4 to 5 months is basically understand uh, all these new design patterns that are popping up, that have popped up in the past few months, and like whatever work is currently going on, and understand finality architectures that are like not related to single slot. Like you saw that Orbit SSF gives economic security, like it steadily increases security in slot by slot. So it's not technically single slot finality, but it is better than I guess what the current implementation is. And like the Orbit paper itself is quite recent, so there could be security issues in that. There could be some other problems that haven't been thought of yet. So like there needs to be a lot of due diligence and research to even ensure that this uh, proposal is also something that has a chance to maybe see the light of the day. And another thing I can work on is basically compare slot and epoch architectures on L1s and L2s, like talking about uh, committee brief confirmations on layer 2s and how those could be different from SSO on layer 1, and what could be a better roadmap for Ethereum. And yeah, I guess that's like, yeah, uh, the title that I had at the start, like secure speedy finality, that is something that Vitalik proposed. That is like a new acronym for SSF that Vitalik proposed in that blog, because as you can see there are so many architectures that are not particularly single slot. So it's like some renaming from MEV, like from minor to maximal, because of the switch from POW to POS. And yeah, that is it about notification. Thank you for listening. Does anyone have any questions?
Yeah, I feel like in other chains like Avalanche or like Near, like they have like subsecond finality, and it's not like a like open problem anymore in other chains. Like, I guess like we are trying to like reinvent the wheel. It's like a kind of like solve problem, the probabilistic finality, the probabilistic consists out of like snowflake or like hot stuff or like white shade, and why not just use them like therapeutic?
Yeah, so like algorithms like hot stuff and like tendermint, basically what the problem is that they're not available if more than 66% of the validator set is offline. No, sorry, if more than 33% of validator set is offline. If they go offline, you don't reach that super majority quorum. And if you don't reach a quorum, then you don't have finality. Ethereum does not want that. Ethereum has made like a decision that it wants to be available. Like the block production must never stop. It should go on. That's why Ethereum has LMD Ghost. LMD Ghost basically whenever like validators propose like sorry not propose a test on blocks, these votes basically add weights to those blocks. So like if you have a block and then there are like two conflicting blocks and then like two blocks after that. So like let's say there's a finalized block and after that there are multiple blocks. Let me just uh, yeah, so like let's say that this is a finalized block and then you have like sub trees. There are like trees. So like you don't know how to choose. So like LMD goes as an algorithm to choose which is the head block so that you can get the canonical chain. And it is done by like, okay, how many votes does this have, how many votes does this have, and then you basically weigh them all together and understand what is the like the most valid block. But then this is a probabilistic mechanism. This is not finality. Finality achieves when there is a vote on a block and then there is a link of justification from that block to another block. So like when you vote on something, you justify it because a previous block has a link to it, and then when you justify another block, you basically draw the link from the justified block to the new block. That is when finality is achieved. And in order for this to happen, there has to be more than 66% votes on that block. So Ethereum right now prioritizes availability, and this existing single slot architectures, they do not provide availability. That's why. Anyone else? Did I answer your question?
Nothing on discussion.
Right, I think that is. Thank you.
Hi everyone, I'm Bastin, and previously I worked at Bright ID on-chain identity and UBI distributions. And since 2 months ago, I've been focusing on 2-3 months ago, I've been focusing on core development, and I found out about the EPF wiki on a random comment on Reddit. And yeah, I've been here. So what I'm working on is adding light client support to Prism. And yeah, so right now the network looks something like this. There are a bunch of full nodes, the consensus, the beacon full nodes, and some of them are validators and some of them are not. And what these nodes have to do is that each of them gets for each block, each of them gets a block header, set of transactions, set of attestations, and some other payloads about maybe slashings or withdrawals or deposits or other stuff. And what the full nodes have to do is that they have to verify the header, they have to verify transactions and verify the state changes. They have to check the attestations, they have to check if there is like other payloads, they have to check that as well. They also have to do the proof of stake mechanics checks, like is the block proposer valid or something. And then after all that, they have to actually apply the state transition function on those transactions and keep up with the chain. And this is a very computation heavy process. So you cannot right now have this on your phone or some low end device. So the concept of light clients has been introduced. And this is what the network would look like with light clients. A beacon light node would connect to a full node that supports light clients, right? And yeah, in that way. And what happens here is that at each block, what the light client gets is these. It gets the block header, it gets a sync committee signature, it's one field, and a sync committee bit field, it's another field, and it gets a list of the next sync committee public keys. And what it has to do is that verify the signature and check the bit field to basically verify the header. and accept or reject that header as part of the chain that the full node is claiming it to be. And it just needs to hold on to the next in committee for the next period of updates and checks that if they are the same. And the light client does not hold any state, so it doesn't have to do any state computations. And it just, whenever it needs, asks the full node about some, like queries the full node about some part of the state. And using proofs, it can, because it has the block headers and it has the chain of the block headers, it can very easily check if the state that the full node is returning is actually part of the chain or not. Yeah, so that's basically what the light client is and what the network would look like. And right now, light client support is only implemented in Lodestar and Nimbus. And so we're working on adding that also to the Prism client. And the roadmap for doing this is something like this. We would have to, we've done part of that, but read and understand the light client specs. And because there is an implementation, a part of the implementation already from a previous contributor, we would have to read and evaluate the code and compare it to the light client specs, and then update some of the implementation that's outdated and add and implement what's left. And then we would have to test it internally using unit tests, and then we would have to test it against Nimbus and Lodestar to see if everything works the same across all the clients. And after all that, we could implement the improvements that the mentor for this project, Mr. Kapka, suggested. I cannot pronounce his first name. And yeah.
So we have two great guests here with us today, Pari and Terence. Yeah, honored to have you here. Thank you so much for coming. Whoa! Because again, the idea of the EPF Day is also to meet the mentors, also to meet the actual people working on the core of the Ethereum, on the client, on the testing, on all these important parts of it. And so one thing that I'm hoping to get you guys can get out of it is that to realize that these people are also human. Like they might sound like these crazy geniuses doing, fixing the whole Ethereum protocol and so on. But they're really just cool people that you can hang out with, that you can get to know them. So that's what I was hoping to do in this panel, just to get to know you a little, and then we can maybe get to some technical topics. If you have any questions, I would say about any part of the protocol, you guys know everything. That's right. But to be specific, Pari is from the DevOps or the Panda Ops team. Actually, I believe you're head of the Panda Ops. Am I right? Yeah. He is like the humble head of the Panda Ops team. So doing the DevOps tooling, the testing, the helping with making the testnets run, and doing the legwork for all the client teams to make sure that they ship something and it can actually run somewhere. Terence is from the Prism client. You work on the EPBS. What do you work on?
I'm doing mostly EPBS these days, but I still work on Prism client. I still code here and there, but mostly on the EIP work.
Okay, so new EIPs, Go, Prism, consensus layer. So we have two experts here, but I believe that if you ask about any part of the protocol, they will have some good answer for you or point you to the right person. So think about some questions, but I have first few questions. And just to start very slowly, just to get to know you, how did you guys get into Ethereum? What brought you here? How did you end up being here today, actually?
Your story is more interesting than mine.
It's all right. It's all right.
I can start. That's easy. So I was first interested, I think, as a lot of people in the space are, with Bitcoin. I heard about it when I was in high school, and the interesting part for me was I grew up in India, and at the time India was still relatively disconnected from the global financial system. And I was under the age of 18, which means you can't really open a bank account or anything. But I still found it cool to, I don't know, build a website and try and get paid for it, or write some words online and get paid for it. Pre-AI generation days, you would have an Indian dude like me write up your website article, and then I still remember, I think it was 70 cents for 100 words or something, which was great, really good money as a high schooler. The problem was I had a PayPal account, and at some point PayPal started doing verification. And once you start doing verification under the age of 18 from a country that isn't PayPal verified, you can forget about that account. I found Bitcoin interesting for pretty much the permissionless reason. Although it was kind of limited, college started, there wasn't that much more you could do with Bitcoin, so I just dig into it deeper. Until I finished my bachelor's, and a friend of mine introduced me to Ethereum. This was, I think, around the DAO. And I thought, oh shit, this is insanely cool. You can actually program money. You can build everything that you can imagine on top of it. I should probably spend some time looking into it. But I was doing an electrical engineering master's at the time. So I was more on the security. How do you make sure that if I have a embedded system in a car, that it doesn't just crash and then hit a wall, right? That's the kind of training I had, the formal training. And that's also the nice thing about university I had moved to Germany at the time, and the nice thing about university in Germany is it's free, so you can actually take up whatever course you want, and you don't actually have to sign up for it. You can just show up at a class and attend it. And that's actually where I met Gonzalo, who's also sitting here. He was doing mechanical engineering at the time, and we both thought blockchain was interesting, and our university offered a blockchain course. Except the first class was cancelled, and since we both hadn't signed up for the class, we both didn't know it was cancelled. We just sat there, expecting something to happen. And the class was held at a facility that's about an hour away from the city. So at some point, it's like the walk of shame with someone you don't know, and like, okay, how do we get back to the city? Do we do something wrong? I don't know. And then we got to talking, and it kind of started the journey into learning more about blockchains and Ethereum. And when it came to doing my master's thesis, I thought this is really cool. Let me try combining what I know about embedded systems along with Ethereum. So I tried like a small project, wrote a thesis about it, and that was my real introduction into the world.
Wait, what was the project? How do you combine embedded systems and hardware and Ethereum?
It was kind of interesting. So I was looking at Ethereum as the way to do key exchange, and then you can reduce the size of the keys you're doing and the size of the keys that you're using. And if you're using smaller keys on really small embedded systems, every byte counts.
Yeah.
So you can offer the same amount of security, but use like a decentralized key exchange mechanism.
Nice.
It was really interesting to just think about it, trying implementing it, and the university was great to like support me and yeah, why don't you do that? And that's, I think, analogous to what you guys have with the EPF today. It didn't exist back then, but thankfully I was in a situation where the university was supportive on the topic. And I think after a few months of looking into it, I wanted to look for a job. Also, practical reasons, needed money, needed visa, all of those things. And I decided to apply at different companies working on different blockchain topics, and one of them happened to be Slockit. So if you guys know about the DAO hack, Slockit is the company that was writing the DAO, so the one that broke the DAO.
Best reputation.
It was amazing, right? So they were at that time they pivoted, so they were working on. I mean, after the DAO, they kind of had to pivot. Right? So they were looking at embedded system, how to combine embedded systems and blockchain. Perfect for me, right? And at the time, they were building the smallest EVM verifier that you can build. It was 500 something kilobytes, and it would fit in an embedded system, and you can send it proofs and verify it. It worked really, really nicely. And it was a great place for me to join. I had the right skill sets for it. The people there were amazing. Like Christoph Jansch was the head of Slockit at the time, and he was literally in the Ethereum founding team. So he would do these sessions once a month where he would just deep dive into like how Ethereum works. And it was a very nice vibe. And it was a small city in Germany, population 12,000. So there's not much to do besides meet with your coworkers. So it was a very, very nice vibe, and I'm still very much in touch with them. And I happened to sit next to the guy who was the DevOps engineer at Slockit, and we got along really, really well. So at some point, I was like, okay, embedded systems are boring. Let me do DevOps. And
DevOps is not boring.
I think my whole life is just like serendipity. Just give yourself the chance and do something. If you find something interesting, just try it out. And I did about 2 years of that. I learned everything I know about DevOps from him. And another point of serendipity is Justin Drake from the Ethereum Foundation tweeted about the fact that the EF was starting a security team. And he just put up like an email address and like, does anyone want to apply? Send your applications here. I had a nice job. I had people I really liked working with. I was like, why not try this out? So I just wrote up a bunch of ideas on what I thought we could improve, a bunch of things I could do, and send it to him. I did not get the security job because I had no training for security. But he found the ideas interesting, so he still had a call with me. And they essentially just set up the DevOps job for me because I had a lot of ideas and was enthusiastic about it. And I was working with Mehdi from the Lighthouse team at the time because Mehdi was doing a lot of fuzzing. And it was interesting how he was doing the fuzzing. They would manually run like 20 fuzzers and manually check that there were issues in these fuzzers. I was like, this is probably a weekend job for me to automate. And that was essentially what I did. And this was still before I even got the job. I had just done like the first interview and I was just like, well, there's an open source project. No one has to give me permission to actually implement this. So I just wrote a bunch of Ansible scripts and I spoke to Mehdi and like, hey, I think I saved you like a few hours a week and probably made your fuzzing more efficient. And I think that's the first time I got really into the ETH2 side of things because I actually had to learn, okay, how is this stuff working? What do you have to deploy? How do they connect? And I think the Lighthouse blog from 2019 November still has a mention of how the automation had find a few bugs just before the beacon chain went live, which is, it was super, super interesting and very motivating. And then since I got a job at the EF, and since then I've been working on testing and security.
Nice.
I think that's the long version of the journey.
Yeah, but thank you for sharing all of that. It's very cool. I also relate to many of it, but I will maybe say it later. Terence, you want to share your
Sure,
story?
yeah. So my story is
Feel free to elaborate.
My story is probably more relatable than most people here. So end of 2017, I bought some ETH. The price went up 20%. And I was like, oh, this is awesome. I'm gonna look more into it. Then I subscribed to this Reddit Ethereum subreddit. Back then, it was a lot more like used in a way. Like people actually use it like I guess the right way to promote technology. So I saw Vitalik post about scalability on Ethereum. So he was looking. Back then, he was working on this roadmap. It's execution sharding. So the sharding through smart contract. And he was looking for teams to work on that. And I was like, well, this is really cool, but I don't know where to start because I have zero knowledge of how Ethereum works in general. And then, but then there are people on the same Reddit comments with the same questions. It's like, how do we start? How do I start? So we created this like chat room basically. And that was Raul and Preston, which I started the journey with. And then we didn't know what we were doing most of the time, but then we know we wanted to work on Ethereum, and then we know we like it to work on Golang, and that is the language we use for Prism. So fast forward 2 months later, we were just like basically making incremental progress, but we're not sure like if what we're doing is right or wrong. Then Xiaowei invited us to this workshop in Taiwan to talk about sharding. So there we met like a bunch of original Ethereum like visionaries, right? Like Vitalik was there, Gavin Wood was there, and a lot of people were there. So yeah, so that was kind of that was the eye-opening moment for me to basically like continue working on it, knowing this is interesting. And during those times, like basically this was a part-time job for me and most people that's working on Ethereum, just because like back then the infrastructure wasn't so good, right? To work on Ethereum, you kind of have to basically have a full-time job. Otherwise, like there's no money to be made, basically, right? And that's unfortunate, but it is what it is. So we're continuing working on it for 6 months, and then we're like, well, we're not making too much progress here, right? This is only like 2 to 3 hours a day, and then we still have a full-time job. And then, I mean, some of us are actually working on this doing full-time job, which we're not supposed to. But then we're like, okay, what do we do? So then, I guess there were some complaints on Twitter, not from me, but people were like, well, if this is the vision we want to do, can we fund this, right? Like, where's the money, basically? And then, like, So then that's basically the funding began. So then we got grants from Ethereum, and then another fun fact, like people were complaining, and Vitalik YOLO sent client team 1,000 ETH at that time. But back then ETH was like $100, so it was like a $100,000. But then that was cool. So we got enough money to do this full time, basically. So let's see, what year was that? I guess so. This was 2018. So end of 2018, we become full time basically on Prism, working on Ethereum, and then there were the first team. I think there was no other team that's working on it. So we're the first team. We're working on this like sharding roadmap, and then on the same parallel universe, there was this like proof of stake roadmap basically, but it's also using smart contract as well, and that was what Danny EIP 1011 basically, and then I guess like at some point during 2018, we're like, well, this doesn't make sense. Well, actually, sorry, before that, Justin Drake, this